Many students feel overwhelmed when they see a summation because there's too many options for what do you do when it looks like this and what do you do when it looks like that. For your own sanity, I have included a useful set of tables at the end of these notes that allow us to sort of categorize our approach. So, when you have a non-geometric sum, regardless of whether it is increasing or whether it is decreasing, you do the same thing for both an upper bound and for a lower bound. For an upper bound, you replace each term with the max. So this was our log of I example and our n squared minus I squared example. We replaced each term with the maximum and then worked from there. Similarly, for bounding below, we did the exact same thing. You drop all but the n over 2 largest terms and replace each term with the smallest thing that you have left. We did, again, that exact same thing for both of them. The only difference is if it's increasing or decreasing, the half of the terms you keep is different, and the number you're plugging in to make it as big as possible for the upper bound is, again, different. For geometric sums, we don't typically bound increasing geometric sums. We use the formula. And for a decreasing geometric sum, we bound it above with an infinite series and replace the sum with the first term of the summation for the bound below. And this is sort of ubiquitous for any summation you'll analyze, this little table. If you don't prefer English, I have also included the symbolic version of these, which are justifiably messy. There's not many ways around it, but this will work for you if you want to see the formulaic way of writing down what on earth are we doing in these various situations. This is what we are doing. This is going to be used a whole bunch as we analyze lots of code, so you will get gradually better and better and better at this as you perform more and more examples.